Lesson 12.3, Dividing Polynomials. Well, let's back up a little bit. What's a rational function? Well, first 5 letters are ratio. So it's a function, and I'll just write it as y equals. We could also write it as an f of x equals, where we have a function on top and another function on the bottom. So x squared plus 2x on top and x plus 2 on the bottom. We're going to spend all our time working with these equations. This one we would actually be able to factor the top, pull out an x, and then we're left with x plus 2 and x plus 2 on the bottom. And then we can actually cancel them. And then we have to do something called the excluded value, but we'll play with that another time. So another example would just be x squared plus 3x on top and 4x squared plus 5 on the bottom. And that's it. You couldn't do anything with that. In the previous lesson, we had things like y equals 2 over x minus 3 plus 1. And I bring that up because we're going to get back to that towards the end of the lesson. That's a rational function, x on the bottom. This is going to cause all sorts of problems for you going forward. But if you follow through the steps, you should be okay. So how do we divide two functions, a rational function, one on top of the other? Well, how would I actually divide those if I wanted to divide them? Well, how do you divide, how do you divide two numbers? This means 147 divided by 26. So that's saying, if we did our long division from way back in the day, 147 divided by 26. Here's how we did long division, and pay attention to this. Most people kind of ignore it because it'll come in handy in a few minutes. We look at the 2 into the 14. We say maybe 6 times. No, that won't be enough. Let's try 5 times. We put it up here because it's actually multiplying by 50, even though we just say 5. 5 times 6 is 30. 5 times 2 is 10. 130. And then we actually subtract it, so we change the sign. A lot of people forget that step, and again, you'll need that in a little bit. And that's it. It's actually 5, not 50. So we would say remainder 17. So this would be equal to 5 and a remainder of 17, 26. What we would call a mixed number. We can do the same exact thing for a polynomial divided by a monomial, divided by a binomial. We'll do them both. Here it is. 4x squared to the third plus 8x squared plus 10x divided by 2x. 2x goes out front. Long division, 4x to the third plus 8x squared plus 10x plus 0. Whenever we're missing something, write in a 0. It's a good reminder so we don't mess it up. Now, how many times does 2 go into 4? Twice. How many times does x go into x to the third? X squared. This causes untold confusion for students. So, what I do is I just take my best guess. And what I think of it as is when I multiply these two together, I should get this first term here. So 2 times 2 is 4. X squared times x is x to the third. If I get the same first term, I did it right. 8x squared plus 10x plus 0 come down. Notice I put a negative out front because we're subtracting. Do it again. What times 2x is 8x squared? Well, the 2 is times 4, and the x is times x. So 4 times 2x, 4 times 2 is 8. X times x, x squared. Put negative. 10x plus 0. Almost done. I happen to know it's going to be 5, but hey, let's check. 5 times 2 is 10. 5 times x, 5 times, there is nothing. It's 1 times x, it's x. 5 times 2x is just 10x. Change the sign. The remainder of 0, but we don't write that in. We just leave it. So, to put it all together here, four x to the third plus 8x squared plus 10x all over 2x. That's the original problem here. All this equals, according to what we got, 2x squared plus 4x plus 5. Now how do we divide x squared plus 2x minus 3 by x minus 1? Same thing. X minus 1, x squared plus 2x minus 3. Much more challenging. Use the x. Ignore initially. So just initially ignore it. We'll need it in a little bit. What times x is x squared? X. Multiply it by both. X times x, x squared. Great. First one matches up. We did it right. Second one just comes along for the ride. You probably forgot. Now we subtract. We have to change all the signs. Tricky. What's next? Well, we got to actually subtract down. We get 3x minus 3. Pardon me, add down 3x minus 3. And now what times x is 3x? Just 3. I don't trust myself. 3 times x is 3x. 3 times negative 1 is negative 3. Change the signs. Remainder of 0. So, x squared plus 2x minus 3 over x minus 1 equals x plus 3. It's beautiful. Keep moving. Other page, other side of the page. There's a few tricks gotta watch out for. This one is not in order. So when you multiply it, there's that. Put it in order. So it's y plus 2, y squared plus 5y plus 4. Now it's in order. What times y is y squared? Y. What is y times 2? 2y. Change signs because we're subtracting. 5 minus 2y, 3y plus 4, plus 3. Multiplying by both. 3y plus 6. Change the signs. I get a remainder of negative 2. Y squared plus 5y plus 4 all over y plus 2 equals y plus 3. Here's the tricky part. Plus negative 2 over y plus 2. The original divisor goes back in as the denominator, so you copy it here. That's your remainder. That's your solution. It doesn't always work out perfectly. The first two I gave you, it did. Now it doesn't. Here's another trick. What's this missing? It's got 4m squared. It's got 13. It's missing the m term. So we're going to put a 0 in front of it. So we don't forget it, because if you do forget it, you will get the wrong answer. Out here we have 2m minus 1. So, how many times is 2 going to 4? 2. M and m squared, m. Hopefully I did it right. 4m squared minus 2m. Change the signs. 2m plus 13. All I need now is a 1. Well, let's check. 2m minus 1. Change the signs. Get a remainder of 14. So, 4m squared plus 13 over 2m minus 1 equals 2m plus 1 plus my remainder 14 over the original divider, 2m minus 1. That's it. That is it. So what's the point? Well, there's a lot of things we use what we call long division in polynomials for, but one of them we can do right now is just simple graphing. How do we graph this? Well, use a calculator is the best answer, but it's 2x minus 1 divided by x minus 2. Goes in 2 times. Change your signs. I'm left with a remainder of, my bad, 3. So this equals, actually leave that space open. This equals 2 plus 3 over x minus 2. Can rewrite that as 3 over x minus 2 plus 2. And we just spent a fair amount of time graphing. And we know that the parent function looks like this. So the plus 2 goes up 2. The x minus 2 goes to the left 2. So we have an asymptote here and an asymptote here. And the 3 means it's stretched out away from the origin. So it probably looks something like this. And that's just one of the many uses we'll use for long division. This is very challenging. It'll be reviewed in class, but you should get a general idea of how it works. Most people find this step right here, multiplying it out, far and away the most confusing. That step's easy. It's finding the right number to put in, the 2 in this case, that is actually challenging. So make sure you practice this, or else you're going to have major problems because things get much more challenging as we move along in the unit. That's it for now. Good luck.